What have cosmologists found? Utilizing our new $10 billion toy, it will be years before that undertaking turns into a reality. On the off chance that it goes as planned, the excursion to Proxima B will take around 20 years. So, sensibly, it will be a very long while before we can confirm if there is indeed life on that planet. The age-old question: are we really alone in this universe? The James Webb Telescope has found some unnervingly human-like things far away from Earth that lead us closer to the answer. Our search for life beyond us has been rampant throughout every human civilization, so much so that we have a great deal of media, writing, and theories regarding this matter. Our wonder regarding our place and loneliness in the universe has been consistent, as if it is instilled within us to constantly look for a companion, no matter how alien-like. Well, we might actually be getting closer to the answers we really need. But are they truly the answers we are searching for? Or are they much more alarming? Join us as we explore the latest discoveries in the realms of galaxies and planets on the journey to find something we might not be prepared to observe. Lights far, far away. Researchers have found what could be the most pivotal revelation in history. Back in 2021, when the James Webb Space Telescope was planned to launch, a very intriguing speculative question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet. For instance, Proxima B, the nearest exoplanet to Earth, is in the habitable zone of our closest neighbor, the small star Proxima Centauri, around 4.25 light-years away. Since the exoplanet was multiple times closer to its star than Earth is from the Sun, Proxima B was believed to be tidally locked, with a permanent day side and night side like our Moon, which faces Earth with the same side consistently. A hypothetical technological civilization on Proxima B could move heat and power from the day side to the night side using photovoltaic cells that generate power out of starlight. Consequently, in a paper with Manas Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since JWST was more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima B. Presently, in 2024, it is possible that the James Webb Space Telescope did exactly that. Using its higher sensitivity and greater range of capabilities, the JWST may have found the lights we were searching for and possibly propelled us into another significant wave of human development. But first, let us delve into the universe of planets and exoplanets to understand how all this was even possible. James Webb's mission explores Proxima Centauri B's mysteries. Since the beginning of time, humans have pondered the nature of the universe. What are we? Where do we come from? And where do we go? These are common yet very difficult questions that humans have tried to answer since they gained awareness. Now, in the era of remarkable technological advancement, one wonders if we are any closer to answering any of the above questions. If you were to ask a philosopher, they would most likely say we are still at level 0 of understanding ourselves and the universe. However, ask an astronomer the same thing, and watch them jump up and down in excitement as they rush to tell you the latest discoveries humans have made about the universe using their clever instruments. Imagine looking at a distant planet and seeing city lights twinkling in the darkness, much like the view of Earth from space. It would be a profound moment, reshaping our understanding of the universe and our place within it. While the detection of artificial lights on Proxima B remains speculative at this point, the JWST brings us closer than ever to making such a discovery. The telescope's ability to analyze the atmospheres of exoplanets and detect potential biosignatures further complements the search, enhancing our quest to find extraterrestrial life. These instruments, although not given much attention by the general public, are very literally a symbol of human progress itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips too. One such method for doing that has been found by researchers and cosmologists. It is through the technology we harness. A particular formation of that technology is now responsible for the new discovery of what could be light on a different planet light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the traditions of human endeavors into space to answer some ever-present questions. Are we alone? Who is out there? Where do we start and where do we end? Well, this infrared astronomy instrument has currently begun answering these questions, although to some extent. What even is Proxima B? Proxima Centauri b, or simply Proxima b, is sometimes referred to as Alpha Centauri Cb. It is a super-Earth exoplanet, and it orbits an M-type star. Super-Earth exoplanets are a class of planets that are more massive than Earth yet lighter than ice giants like Neptune and Uranus. They are really unique. They can be composed of gas, rock, or even a mix of both, and their sizes can vary from twice the size of Earth all the way to 10 times its mass. They, as a matter of fact, put the super in super-Earth. Regarding Proxima b, it is a super-Earth and an exoplanet, meaning it is a planet that crosses outside the solar system. The very first possible evidence of an exoplanet was found in 1917, although it managed to stir little interest and recognition. However, in 1992, the first confirmed detection occurred, which left researchers puzzled. Another exoplanet, which was first detected in 1988, was confirmed in 2003. As of the 1st of April 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of them, 896 systems had more than one planet. These brilliant discoveries are orbiting an M-type star right now. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have very low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. The elusive stars have variable definitions and names depending on their temperatures and sizes. For instance, M dwarfs or M-type main sequence stars yield a maximum temperature of 3,500 K, thus getting their name and traits. Returning to Proxima b, its mass is known to be equivalent to 1.07 Earth masses. Interestingly, it only takes 11.2 days to complete one orbit of its star compared to our 365.25 days. You can estimate the size of the star Proxima b is orbiting incredibly under the estimation of the whole electromagnetic spectrum. The star has a total luminosity of only about 0.17% that of the Sun. Also, in the visible light range, its luminosity appears to dim even more as it seems fainter. It only illuminates 0.0056% of the Sun's luminosity in the visible light range, emitting a significantly lesser amount of light energy when compared to the Sun. More than 85% of its emitted energy is in the form of infrared radiation. Proxima b's discovery was reported way back in 2016. You might be asking why Proxima b? There are a large number of stars. Well, there are a few reasons that add to the strong fascination cosmologists have with this place. First and foremost, Proxima b is the closest known star to our Sun. By definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Therefore, Proxima b, our nearest known star, is high up on the priority list right now. It is also part of the triple star system called Alpha Centauri, and despite Proxima b's low luminosity, the system itself appears as one of the brightest star clusters in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri b is that it could potentially be habitable since it falls under the habitable zone. The possibilities surrounding this star are endless, and hence cosmologists have taken on the mission to explore the depths and limitations of the potential of this star. That's where the James Webb Space Telescope comes in. The four main goals of the JWST are to look for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and study planetary systems and the origins of life. As the JWST continues its exploration of the set exoplanet, we get closer and closer to the culmination of these missions. From SETI to exoplanets, looking for alien life. So what exactly is SETI? Considering that humans have always been a curious species, poking and prodding into literally everything that moves and doesn't move, it makes sense that a mission like SETI came into existence on such a large scale. Imagine that God has orchestrated a grand cosmic scavenger hunt, but with a twist. Instead of gold, we are tasked to be on the lookout for signals, more specifically electromagnetic whispers, from civilizations beyond our imagination. SETI is short for Search for Extraterrestrial Intelligence, and it is our collective effort to detect secure signs of intelligent life lurking amidst the stars. Our curiosity never ends. Does it? Way back in the mid-1890s, shortly after radio technology came into human use, pioneers like Nikola Tesla and Guglielmo Marconi thought of a groundbreaking idea. They actually hoped to use these newfangled radio contraptions to contact Martians. How bold of them! Moving to the present, SETI now employs an extensive range of strategies to locate extraterrestrial intelligence. We have developed radio searches for the distinct purpose of capturing narrow-bandwidth signals. These signals can be scattered across the galaxy, transmitted by other technological civilizations. You might be thinking, why narrow bandwidth, right? Well, in the vast cosmic symphony, nature usually orchestrates broadband choruses. Only intelligence might choose to sing in specific narrow ranges, making narrow bandwidth signals akin to cosmic breadcrumbs leading us to advanced civilizations. Moreover, SETI is not limited to radio waves. Optical SETI is another fascinating branch where we hunt for laser beams that extraterrestrials might use to communicate across the vast void. These high-intensity laser pulses would outshine any star in their path, acting as beacons for those savvy enough to look. With an array of observatories dedicated to this task, like the Allen Telescope Array in California, we continuously scan the heavens for these telltale signs. However, SETI is a needle-in-a-haystack endeavor. The cosmos is unimaginably vast, and our search spaces are immense. We rely heavily on algorithms, computing power, and a bit of luck to sift through the torrents of data. Despite the challenges, every flicker of potential signal keeps our hopes alive, and the quest continues unabated. Interestingly, there's more to our extraterrestrial pursuit than just listening and watching. Projects like Breakthrough Listen aim to cover unprecedented swaths of the sky and bandwidth, using some of the world's most powerful radio telescopes. Simultaneously, initiatives like the James Webb Space Telescope, with its advanced infrared capabilities, allow us to peer into the atmospheres of exoplanets, looking for biosignatures that might hint at life. The pursuit is a humbling reminder of our place in the cosmos, driving home the point that, while we may be searching for others, we are also in the process of discovering ourselves. The final frontier is not just about finding alien neighbors but understanding the very fabric of existence. How JWST could identify city lights. One of the many features of Proxima B that caught scientists' attention is that it is tidally locked, meaning it has a permanent day side and a night side. This characteristic could be crucial for detecting artificial lights on its surface. If there is indeed a technological civilization on Proxima B, it would need to find a way to illuminate its dark side. Thus, city lights or large-scale artificial lighting could be a potential indicator of extraterrestrial life.